Hi everyone, and let's welcome to this session. Let us learn Google Kubernetes Engine. So prerequisites for this is you must have a little bit knowledge of Docker, basic knowledge of Kubernetes, and if not knowledge, just understanding of it. Okay, so let's take a look at Google's implementation of Kubernetes. Right, Google is the initial and main developer and largest contributors to the Kubernetes ecosystem. Okay, so to access Google Kubernetes Engine, go to the navigation icon on the top left hand corner, and then find out Kubernetes Engine. Okay, you can use this small little pin here. If you use this pin, it will be highlighted and will be listed into the pinned services. Right. So just left click on it and it shall load the Kubernetes Engine page. For you, it may ask, just like it is asking right now, to enable Kubernetes Engine API. So all the communication in Google Cloud Platform happens via the APIs. Okay, you can only communicate with Google Cloud Platform, whether it's console, whether it's SDK or anyhow, right? However you connect, you must connect via the APIs. You must enable the APIs beforehand. So we just enable the APIs, right? After enabling the API, the first thing we must do is to create a Kubernetes cluster. Right? What is a Kubernetes cluster? Kubernetes cluster is a combination of underlying infrastructure, okay, that gives you the nodes where you will have all the resources, that is CPU, memory, storage, etc, etc. Right, so let us create a cluster and take a look at the Kubernetes nodes or the Kubernetes cluster in real time. Right, so there are two options. One is the GKE standard, the Kubernetes engine standard, and one is autopilot. In autopilot, you are charged based on the pods you deploy, and everything else that is deployed for you to be able to deploy the pod is done via Google Cloud. Okay, the entire management remains with Google Cloud. You do not need to worry about it. However, if you want ultimate control of your Kubernetes cluster and you are willing to pay per node, you will select the standard edition. So in this particular case, we will go ahead and select the standard edition and select configure. There are only couple of options we need to configure to be able to be able to use Kubernetes clusters. Okay, and there are a lot more advanced settings. So this course is intended for the beginners or the introduction. Okay, we will cover all the advanced settings in the advanced session. Right now it is only for the introduction, so we'll just go with all the bare minimum requirement to get up and running. So the first requirement is that you should select a regional cluster. Regional cluster has a higher availability, and I have selected the region as your central one. You can select any region where you want to deploy your Kubernetes cluster. The next setting we will change is the number of nodes per zone, right? From 3 to 1. We have to do this because by default with the initial account, there is a limitation of 8 vCPUs per region. In this particular case, if we deploy 3 nodes, each node requires 2 vCPUs. So because we are deploying only 3 nodes here, okay, 3 nodes in all zones, so we'll need 6 vCPUs. But if we select number of nodes per zone to 3, the total number of zones is 9, and that will require 18 vCPUs, which is out of our quota limit. We'll just set this to 1. You can enable auto scaling. I am not doing that. I do not have the required quota for this. In surge upgrade, it's saying if you want to upgrade during the surge some of your resources, whether you want to do it or not. I'll leave that alone for now. In the nodes, by default, it selects EC2 with the 4 GB RAM, right? To be able to deploy your applications that are little more than standard, you will require more than 8 GB of RAM per node. For now, I will leave it to default. We'll run with 4 GB of RAM. Okay. You can leave all other settings to default as is. No need to change anything. Then click on create. This will create my first Kubernetes cluster for me to be able to deploy any applications in Google Kubernetes Engine. So let's wait for it to create. It takes about a minute or two. My cluster is now created, and I have 3 nodes running with total of 6 vCPUs and 12 gigabytes of memory. Let's take a quick look, and on the initial page it will show you what version of GKE are you using, what is the total number of nodes in your cluster, what sort of automation are you using, what is the networking for this Kubernetes cluster, what is your cluster pod range, what is the service address range, and etc. etc. You have all the settings that are available. So we will not get into this. First, let's understand the cluster and how it works, and we can quickly deploy an application to it. So as I stated earlier, we have 3 nodes. These are all the names of the nodes. These are again virtual machine deployed in my compute engine by Kubernetes for me. Okay, these are not physical machines. If I go to compute engine, by default, I'll see there are 3 instances created for me, okay, with an external IP. So I can disable these settings. If I want to harden the security, I can disable all the external IPs and so on. But if I go here, so these are the settings available for my node. For the storage, I do not have any persistent volumes that I have defined yet. So when I do when I define my application, when I create them, that's when I will define the storage as well. So log level is again, my cluster is going to use default severity of the log levels. As you can see, some of the logs are already generated. These are system logs, right? Let's go ahead and deploy one application. Okay, so you can deploy applications in Kubernetes Engine in various ways. You can do it from the Cloud Shell, you can do it from the command line, you can do it from the Cloud SDK, or you can do it from the GUI. Okay, for now, for the ease of use, let's do it from the GUI. So here is the deploy button. Click on deploy. Being the container orchestrator, right? The Kubernetes engine. What is Kubernetes engine? It is meant for the orchestration of your container application. So what do we need to deploy an application? Your container deployment image, right? So right now, let us use the existing image that is running the nginx web server in it. Okay, and we don't want to set any environmental variable right now, so that is fine. I'm just selecting the nginx. The image is already available. Now if you want to deploy your own image, how to do that, we'll take a look at that shortly. What is the name of my application going to be? It's going to be nginx. The namespace is going to be default. Namespace is again a Kubernetes context wherein you deploy your application which are part of a specific namespace. It differentiates you from the other application. I'm just deploying it in the default namespace that is created by the system for me. I can create my own namespaces. And now before I could deploy, I could also modify some of the parameters within the YAML file if I want to. Okay. So here is what everything to do with Kubernetes Docker container mostly is configured within the YAML files. Okay, yet another markup language. So here there are different segments, different parameters, and how you can configure it. So the important points to note here is that it is deploying the image of my nginx container. It is using the latest image tag. Auto scaling is enabled, so it's the minimum number of container it's going to deploy is 1 and the maximum is going to be 5. And what type of CPU utilization it should reach to be able to scale up, that is 80%. So if it's utilizing 80% or above, it will do the scale up operation, right? And what will be the name of my autoscaler is this. So a lot of things like this are configurable options that are already done by Google for you for the sake of understanding this. Okay, so I'll close this. And to which cluster do I want to deploy this application? So if you had multiple clusters of Kubernetes Engine, you could select whichever cluster you want to deploy from the drop down. Right now I have only one cluster, so only one is listed. I'll select that and select deploy. So now it is deploying my nginx application to Kubernetes Engine. Okay, so it is using the existing cluster image, it is creating a deployment, and it is deploying all my pods. Okay, now all the pods are deployed. In theory we will see what are pods, what are services, what are auto scaling pods, and what is a deployment. Deployment is basically the automation of complete deployment, as the name itself suggests, complete deployment of your stateless application. What are the pods? Pods are the smallest deployable unit in Kubernetes. The pods contain your image. Okay, so when you run an image via Docker container, you call it a Docker image or Docker container that is running. Whereas in Kubernetes, whatever application you deploy in form of containers is called pods, right? So how many pods do we have running right now? We have 3 pods running. So our setting was that we'll have minimum of 1 replica, maximum of 5. Okay, here we are running of 3. By default the system determined, Kubernetes determined that I'll be running 3 pods at a time. Okay, I have 3 pods running, they are up and running and they are accessible. Okay, so if I go if I want to log into one of these pods, I can log in right now. Now how to log in using the kubectl, that we will see shortly. But is this nginx application that I have deployed in my Google Kubernetes Engine available out of it to the outside world for the others to access? No, not yet. So how will that be available? How does that work? For that, you have to expose your application to the outside world. Right? The correct word or terminology within Kubernetes Engine is export. So there is an expose here. Click on this expose button. So what this expose will do, it will create a load balancer. Okay, it will create a load balancer service with a public IP address and then expose your application over that public IP address. Right? So if you see in a diagram here, we have our service, which is what we are creating. When we expose, we create a service. It is going to connect, my service is going to connect going to be the front end of my application. So any incoming communication with my application has to go through the service, right? So right now I'm going to expose this to a public or an external IP address. Okay, so I'm going to choose load balancer. If I have an application that does not need to be published over the internet and it is only meant for the other internal applications and services to be accessed, I will select other ports. Okay, so for now I want to publish it to the internet, so I'll select load balancer and click on expose. This will create a load balancer for me on behalf of me. Okay, I don't have to do that, Google will create it for me. It will assign an external IP address. It will assign an external IP address and my service, my application will be exposed to the internet via this load balancer so that the intended users can access. Okay, it will take a couple of minutes. Okay, so after a couple of minutes, our service has been deployed and here is the external endpoint. That means here is my load balancer IP address where my application is accessible over the internet. If I simply click on this, it will load the nginx page, because right now I'm running the nginx in the backend, right? So I will explain the entire procedure shortly, how this works, and how we have set this up, right? So we have a cluster IP here. We have the load balancer IP. Why do we need cluster IP? Cluster IP is the destination of my application within my Kubernetes cluster. Okay. So this concept is a little bit complex, but we will take a look and I will try to make you understand the entire procedure. So right now our application has been deployed. If I go to workloads, I'll see my application, that is nginx, and it is exposed to the internet, to the outside world, over the using the nginx-service on this particular external IP address. Right. Now let us understand how this works. Right. So let us understand how this works. If you go to the service or your application details, it will say what is the label selector. It is the nginx, that is the image that you are deploying. It's the label for your nginx. What is the container it's running? There is only pod specification is one pod. Okay, sorry, the revision is one, and then it is running the nginx container. Okay, minimum replicas is 1, maximum is 5. If I go to my service details, I see again the selector is this, the type is load balancer. Okay, and it is using this particular external IP address. Ingress is set to true, hence I am able to access. If you have deployed this and if you are not able to access in general, okay, if you have deployed you have logged into the Google Cloud Platform for the first time, you have deployed nginx, you followed through all the procedures that I did, you are still not able to access, there is one catch, and that catch is that you have to ensure that you have enabled the port 80 in your firewall. Okay, so go to VPC networks and go to firewall. Your Kubernetes cluster will utilize your default network unless you change it. So as you can see, Kubernetes has created its own rules while it was being deployed, and some of these rules that I have manually created. So you will have to create one of such rules wherein you will allow port 80 connectivity from outside the internet towards your ingress, okay, towards your instances, and hence it is working fine. So let me start with a quick explanation of what we just did. Right. So the first thing that we did is deployed a Kubernetes cluster. In this case, Kubernetes cluster consists of 3 nodes, one node in each zone. Okay, there is a region, and in that region there are zones. Let's call it zone 1, 2, or 3, or maybe less A, B, and C. Okay, and in that zone we have deployed single node each. Okay, so that will protect you from any sort of failure at the node level. Now you might think because you have put these apart in different zones, what about the latency and the kind of problems that you might face? Here we are explicitly using Google's internal network, which is extremely fast, so there will be no latency. Okay. So we have 3 nodes running, which we deployed. Our Kubernetes cluster is created. Now, whenever you do a Kubernetes implementation, you have to define your own networking, because the concept of Kubernetes or the concept of containers is that you have your application and required libraries. Okay, so that's your app plus libraries, and you are packaging them together as an image or a container. Okay. Now this image is extremely portable. You should be able to deploy this anywhere. Okay. And then inside of this, you will run your stateless application. Okay. That's again app and lib. Now the purpose of the image is that it to be portable. Right? It should be we should be able to run it on any of the underlying hardware infrastructure, whether hardware or software. It should be portable, right? So when we create a Kubernetes cluster, okay, we have to define networking, which is very important part. Right? So we have our 3 nodes. They all have by default in Google Cloud, they all have 2 interfaces. Okay, which here onwards we are going to call so 2 interfaces. So 2 physical ports where the cables are connected. Not physical in this case; it's all virtual. But where the virtual cables are connected, right? So one of them is the public IP, okay, and one of them is internal, okay. And now when we deploy multiple containers into the nodes, let's see, I am deploying 4 containers here. Because it being the the microservices architecture and it being the container, it is isolated from the other containers even if they are running on the same node. Okay, so the underlying operating system, let's say it's a Linux operating system. Okay, mostly you'll run 99% of the containers on Linux. Okay, unless you have some specific requirement to run them on Microsoft Windows. Right. So each of these containers, if they want to communicate with other container, okay, if a container wants to talk to another container, what you cannot talk directly. What you need is a service. Okay, so let me erase this for a second. Let's understand this. I have a container 1 running on node 1. Okay, let me draw a container here. I have one container here. I have another container here running another application. I have one more container here running on node 2 and another one on node 3. Now I want to be able to communicate among these containers. So what do I do for that? Right? To be able to communicate between the containers, you can't directly do that. So you have to introduce something called service. Okay, or you can utilize the containers. You can assign an IP address internally and connect them together. Okay, so the best way is to do service, because that way you will monitor the intra container traffic, as well as you'll have a better control over it. So this service that you are creating, okay, it is container specific. Okay, if you want it to be. So if I'm creating one service, I'm saying that for this service, whatever backend is going to be my container 1. Okay, let me number these containers for the sake of convenience. Okay, so this service 1, okay, S1 is going to connect to my container 1. Okay, now this service I can expose it internally over the node port IP. Okay, so what will happen if I expose it over the node port IP or the internal IP? This will be available only within the node. Okay, only within this context. Can this service connect to, let's say, a container service running on the another node? No. Okay, so that is one way of doing it. The other way is, let's say I have put these into a cluster and I'm calling this cluster virtual IP addressing called R2 here. Okay, so R2 is going to be my cluster IP range. So what I can do is I can assign this service a cluster IP, so that the other services running on the other node, for example S2, can connect to my S1 service, okay, using the cluster IP. CIP, let's call that for a second. So because all the nodes are connected to the cluster, okay, they all have the access to the cluster IPs, but not necessarily they will all have access to the node ports. Okay. So there are three main concepts when it comes to service. One is node port in Google Kubernetes Engine. Second is the cluster IP, and the third is external IP. The third, external IP, does not reside within the context of your cluster. It's outside of your network. It's outside of your container. It's called external. So to utilize this external IP address, basically we set up a load balancer with the external IP address and point it towards our services running in Kubernetes cluster. So that's what we did in our example. We created a 3-node cluster. For example, this service number 4 is our pod for nginx. Okay, nginx. This is our pod for nginx. Okay. And we are running a service here. Okay, it's listening on port 80. But to be able to access this from the outside world, what did we do? We exposed it. And while we are doing expose, we set that create a load balancer for my nginx service that will redirect outside world traffic, okay, to my correct pods. Okay, so that is what we did. We created an external service with a load balancer IP, okay, not with internal IP, because I wanted to expose this nginx service to the internet so that I can access. Now we can create one more nginx service called nginx2. Okay, and what we will do, we will only use the cluster IP. Okay. So will I be able to expose that to the outside world? No, it's not going to work. So what is the benefit of this then? So this type of configuration is required when you want to have intra application communication between your microservices. Okay, you don't want it to go out. You'll have only one public facing or the external service, but most of your services are going to be internal. So let's take a look at that. Let's go back. I will deploy one more service. Okay, I'm going to again use the same image. Continue. Call it nginx2, which is also fine, and deploy. So for example, earlier we had created one nginx implementation. Now I am creating another implementation of nginx, another pod with the nginx2. Okay, so here my nginx2 workload or pods are also running already. Okay, they're all good to go. Now let me also deploy or expose this. Okay, because without expose, do you see any IP address here? No, it doesn't have any IP address. It's running, but it cannot communicate with the outside world. So to be able to communicate with the outside world, I'm going to expose this. Click on the expose button. I'm going to expose this on port 80 because that's the default port. Instead, I'm going to select a cluster IP instead of the load balancer and then expose. So what I'm doing, instead of allowing my node nginx2, okay, it could be running anywhere, but my nginx2 service to be able to communicate over the cluster IP instead of a public IP. Okay, so nginx2 service is created and I believe it's also exposed. So this service 2 is what it is, and then I have received the IP in the range of 10.191. Okay, so this is a private series IP address. If I try to access, it's not going to work. So you will say, what is the use of it? It is going to work If I log into this nginx1 instance and try to connect over the cluster IP internally, it will work. So how do we do that? To be able, because all these pods are running Linux operating system, I will have to log into command line, okay, and connect to the pods running for the nginx1 service and try to access the nginx2 pods, right? So to be able to do that, I'll have to go to Cloud Shell. So let me open Cloud Shell, and now slowly but shortly, we'll also start introduction to the kubectl. Okay, kubectl is a command line interface that you will use to interact with your Kubernetes cluster. So the first thing you have to do is you have to set the context. So if I, let's say if I do kubectl, okay, this is a command line tool, get, and I'll say cluster info, okay, or just kubectl cluster info. So it's not gonna get anything because my command shell is there, but it's not connected to my Kubernetes cluster. Okay, so let it complete its thing, and then I will connect it to the Kubernetes cluster. To be able to connect to my cluster, I have to get the credentials for that first. So basically, I have to tell my shell which Kubernetes clusters to connect. So for that, run a command gcloud containers, okay, clusters, get hyphen credentials, okay, then the cluster name, and then the region. Okay, so now I have the credentials for the cluster 1, and I'll be able to view that if I'm to look for the settings. Wait, basically your shell will maintain a .kube file, right? So it's a directory actually, .kube, and if I just do config, it will tell me to which cluster I am connected right now. To whenever I execute my commands, where will I be connected? I'll be utilizing this endpoint. So if I run the kubectl cluster info command now, I should be able to list the, or yeah, there it is. So it's listing where my Kubernetes is running, what is my control plane, where is my DNS, what is my metric server, etc. These are core Kubernetes concepts, so we can take a look at them later. But for now, let's try and understand how our application is working. Okay, so we are able to connect. Now let's do get pods. That will list all the number of applications that we are running. Now we are running two separate set of uh, pods, one for the nginx1 service and one for the nginx2 service. Two application, one for the nginx1 application, one for the nginx2 application. So now I'll do kubectl get service. Here I have the three services running, as you can see. First, the first one is default, or let's say the system service for the Kubernetes pods running on this particular cluster IP internally. Okay, so we'll see how we can connect to that and do what actions do we need. But the ones that I created, so the two services, one is utilizing the public IP, external IP, okay, and it is listening over the load balancer. The type is load balancer, and the second application service that I created is connected over the internal IP. Okay, so if I log into my one of the pods from my application 1, if I want to connect to the application 2, I will only be able to connect it over the cluster IP and not over the external IP because it does not have one. Okay, so let's see that in action. kubectl exec, that's the command to attach to your pod, then the pod name. So let's attach to application 1. And what command do I want to run? Okay, I want to connect to the bin bash. kubectl exec is deprecated. Use kubectl exec. Okay, so basically it does not like the IT extension that I had added. And right now I'm already connected to the pod 1. Okay, so what does that mean? Now in this context here, because my application is nginx 1 is running here on these containers, I'm logged in to this container using command line. Okay, now let me try to connect to my nginx service over the cluster IP of my application 2. Okay, I'll just do CAURL, which is command line, to access any web services, and as you can see I'm able to access. Okay, I'm able to connect to my application 2 over the application 2's service, and vice versa. If I want to connect from the application 2 to the application 1, I'll be able to do that also. So if I'm just logging into the application 2, just pick any one. Now go back, and then paste. Okay, now I'm logged into my application 2. If I want to connect to the internal IP address, I'll be able to do that. Okay, see that is the internal IP address of my first application service, and I'm able to connect, as well as I can connect over the external IP address. There. Okay, so that is how we can interact with other services within the Kubernetes cluster. That is how your application will interact with its subcomponents. So for example, you are a banking, or let's say if you are a e-commerce system, right? So you will have in your e-commerce system, you'll have one application that manages your customer data. Okay, let's call it CRM. Another application that manages your payment data. Okay, so it will have your payment gateway, etc., etc. Payment. Okay, another one, you will have your order data, right? Order, etc. Okay, so instead of creating one monolith application that serves all these three purposes, you will divide them into multiple applications, and create three different applications. And the benefit of this is that if you want to update your payment system, your other systems will not be affected. If you want to update your CRM, you can easily do that. So you have more control over your services. So that concludes our Kubernetes demo. In the next session, we'll talk about persistent storage. Okay, all of these are stateless right now. So all the applications that we have deployed here, the page that you're accessing, if I make any changes to that page, if I make any changes here to this Kubernetes, because we don't have any persistence configured, as soon as these pods are restarted, okay, all the changes are lost. They'll be restarted from a base static image. Okay, so we'll learn that in next session, how to configure persistence.